All right, so we are going to explore some scientific notation. We've done some of these in our warm-ups, so some of this is going to be review, but we are going to start out with, maybe, let's see if it'll click over. There we go. Just exploring this table and making some observations. So we can express numbers as products using powers of 10. So here are our numbers, and here's the powers of 10 that represent these numbers. So we're just going to go through A. As the exponent of 10 increases, so as our exponents get bigger, the number becomes greater. Is that true? So our exponents get bigger as we go up the table. Our numbers get bigger as we go up the table, so that is true. A negative exponent of 10 makes the number negative. So here are negative exponents. Are our numbers negative? And the answer is no. The exponent's negative, right? Negative exponents, but not negative numbers. So that is false. 5 times 10 to the third is greater than 5 times 10 to the second. And that's true. 500 or 5,000 is greater than 500. So this one's true. 5 times 10 to the negative 3 is greater than 5 times 10 to the negative 2. And that is false. Because 0.005 is less than 0.05. So 5 times 10 to the negative 3 is not greater. They kind of follow the same rules. The further away from 0 the exponent is, the smaller the number. All right, so what is scientific notation? All right, so scientific notation is written as a product of two factors. One factor is greater or equal to 1 and less than 10. Then the other, so and the other, a power of 10. So basically what that comes down to is two things have to be true. Number one, our number is between 1 and 9 as a single digit. Right? And number two has to be 10 to a something power up here. All right? X, we're going to be putting actual powers there. So maybe it's like X, for example, 10 to the 15th. Just an example. So 6.92 times 10 to the 5th. We're going to label this. So notice this is between 1 and 9. So that's good. We have our power of 10. And then the fact that it has the times in between makes it a product. So, I mean, I guess technically there are three things we need to make sure we have that product going for us. All right, so example 1. Which of these are expressed in scientific notation? A is not. Y, not written. I guess it's not that it's not written, it's not less than 10. All right, 5 times 2 to the 10th. This is what gets us on this one. So it's a no, not base 10. All right, 4 times 10 to the negative 3. That one is. We have a single, between 1 and 9 and a base 10. So that's a yes. 2.7 times 10 to the 120th, that is also a yes. We have everything that we need for that one. E is no. It's not a product, not written as a product. All right, 7.5 times 10 to the 0, even though that's to the 0, this is still in scientific notation. 10 times 10 to the 6. Nope, this one's going to get us because it is, again, not less than 10. So no, not less than 10. All right, and the bottom one, again, is a no, because it is not greater than 1. I love that I'll write less than out, but I want to use an inequality for the word greater. Anyway, moving on. But that's what we're looking for. We're just looking for, is it a product? Is it between 1 and 9? And is it a power of 10? All right. So what I didn't put in here is a slide explaining what these E's are. In a calculator, many calculators will, instead of writing times 10 to the, because it's all in one line and they don't always have the exponential function, they use the letter E to signify that it's an exponent. So to match these, what I do is, if it's multiplication, that's going to be a positive. If it's division, it's going to be a negative. For the multiplication, I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then I'd have to go between the 5 and the 2, which makes 15. So this 5.2 E plus 15 would be 5.2 times 10 to the 15th power, which is A. Going to this one here, 5.2 times 10 to the 17th power. That's going to be our other multiplication, but just so you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Move it between the 5 and the 2, that makes 17. So this one is answer C. All right, now with answer D, because the way scientific notation works, even though we haven't explicitly talked about it, we're going to count how many moves. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to take one of those away. So this is actually -7 moves. And so our answer is B. Because this would be 5.2 times 10 to the -7th. This one is 5.2 times 10 to the -10th, which is going to be D. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 minus the 1, we get 11. And I believe that is it for an intro to scientific notation. Next video, we're going to talk about scientific notation with big numbers.